Hey everyone, welcome to the Kate's Control Systems, our first webinar about TransferMinder, avoiding costly unloading errors. That's what we're going to be talking today. We'll have a few more webinars after this on the same subject, but this is the first webinar. We're going to talk about building a foundation, sensors, and using some technology, and then we'll explore the topic further on the next couple of webinars. So let's get right into it. By the way, we're going to move swiftly. If you don't know much about technology, that's okay. We're going to do a very introduction at the beginning, and then we'll move through some additional topics, RFID, things like that. So if that's the part you're tuning in for, that'll be coming up in a few minutes. But we want to just basically cover the foundation to get started for those who maybe are in quality improvements and things like that that aren't as in touch with the technology on the factory floor. So the first question we want to talk about is the sensors detecting problems. How can we use sensors to detect problems or prevent problems? Let's take a simple scenario like we have a hopper, bin, or tank with something in it. It could be pellets or liquid or anything. And we're going to move that product over to a destination hopper, tank, or whatever it is. If it's something really simple like this with just one pipeline, there's not much chance for the wrong stuff to go to the wrong destination. So when we open the valves, we know where it's going to go. So we don't really have a problem here. What we do have is we have a situation when we start adding more complexity to the situation, we have a source bin going to multiple destinations. And in this case, we have three-way valves, and a lot of you may be familiar with those, but what a three-way valve does is it allows the liquid perhaps to go maybe through the first valve and into the fill position of the second valve so we can guide the liquid. So inside, if you don't know what a three-way valve looks like on the inside, it looks like this. It's a T port, and that T rotates 90 degrees. So in this case, the first valve's in the through position, the liquid would go right through. And then on the second valve, the T port is rotated 90 degrees, so the liquid would go down into that tank. So you put them together, and now we know where the liquid's going to go. But how do we know the path? How do we know where the liquid is going to go in this case? How do we know that that blue stuff is going to go into the blue tank? Well, what we're going to do is we're going to add some sensors. In this case, we're going to add some limit switches. For example, on the first valve, we're going to verify that the T port is in the through position, and the second valve, we're going to verify that the T port is in the fill position, so we know where that liquid is going to go. Well, what do those limit switches do for us? How do they work? Where do they go? Well, those could do a lot of things, but they could maybe light some pilot lights on the wall. For example, the operator could look at the wall and it could light up the through light and the fill light on the two tanks. So that could be the simplest application of how you could use those sensors to just verify, just something that would enunciate things are in the right position. Indicator lights. Now let's talk about another scenario where we replace pipes and pumps with maybe conveyors. Now what we have is we have a hopper perhaps with some blue pellets, and those would go down through maybe some drag chain conveyors that would get pulled over and put in one of three destination hoppers. And let's say we had in the middle there a manual diverter chute. So that means that we could maybe push that diverter to either the red, blue, or green hopper and route the material to wherever we wanted it to go. On the left side is a manual slide gate. That could be something that you just pull open manually to let the pellets out of the source into the conveyor. And then usually each of those conveyors is driven by a motor. So that will pull the product through the conveyors and down into whichever destination hopper is selected by the diverter chute. Well, what we can do here to already improve things is we can add some sensors, and the sensors will help us to know the path. So for example, on the left, we know right now that the manual slide gate is in the closed position, so there won't be anything coming out of the source hopper. And then we have the diverter is in the B position or the middle position to the blue hopper, and we can confirm that with those limit switches we talked about. So in this way, we could know are we receiving material? Is the slide gate open? And then we could know if the diverter chute is pointed to the right destination hopper. And in this case, we could load whatever color pellets we want into the source hopper. In this case, it might be blue, but it could be anything. And then we could move the diverter chute to the destination hopper that we wanted so that they could match. That's like the minimum amount to make sure things are going in the right place. So now let's think about opening the position. Now we can see on the left that the manual slide gate is in the open position, and the diverter chute is in the B or blue destination. And now we have verified the path. The diverter's in B and the slide gate is in open. So now we could run the conveyors. We could turn on the conveyors. So now we would actually be moving product through the system, through the conveyors into the blue hopper. Okay, let's move on to a situation where we have an unload pit. So instead of having a hopper with conveyors, let's consider that we have a rail car. The rail car would sit over a collector, or commonly called a pit. And if we were to open the slide gates, chutes, or valves, or whatever the rail car has, then it could discharge into the pit, and then the conveyors can carry the material across and then up the incline. And this could be, by the way, a lot of conveyors on the way into the plant. This could be conveyors, it could be pumps, it could be a liquid, it could be material, it could be a lot of things moving, and it could be a lot more conveyors. We're just trying to consider a really simple case here. So from the top, if we were to look from the sky, it would look like this. We'd have a rail spur that would come off the main line for the plant, and there could be a lot of rail spurs, but we're just showing a really simple case. Then this area of gray, that's the cement area, and the pit would be there. Usually it would have a cover so that no foreign material would get in there when you weren't unloading. So you'd open the cover, and then you'd pull in the rail car like this, maybe with a tug or some other way to pull it around the rail system. And then when you open the chute and everything, you can get the material to come out. So in this case, the unloading pit would actually be underground underneath the rail tracks. So that's the way a lot of plants have it. They have maybe a multitude of rail spurs and maybe several unloading pits, unload stations, and then those can be conveyors, or they could be pumps, whatever kind of material you're moving from the rail car into the destination. So here's the problem. What don't we know? What can't we confirm? We've confirmed things like limit switches. We know the diverter's in the right place and everything. Well, what we don't know is what's in the rail car. Is it the blue pellets? Is it the red pellets? Is it the green pellets? We just don't know. It's not obvious from outside the rail car. Now, you might be thinking, hey, I could climb up the top of the rail car, open the hatch, and look inside. But that's a little bit problematic. One, that's pretty tall. If you've ever stood right next to a rail car, they're pretty tall, and you'd have to climb up the ladder and look inside. The second problem is you might not actually be able to see what it was. I mean, could you tell the difference between water and, I don't know, carbonated water by looking inside the top hatch? I'm not sure. If you used a flashlight, you have a danger of dropping stuff into the product, and especially liquid, that would be a mess. So the next thing to consider is, how do we track these rail cars? How do they arrive? How do rail cars get into the plant? Well, in reality, they come at all different times and dates. So the rail cars show up. You might order the rail car, but it's got to get to you over the rail system. The company is going to bring it to you, but it's not like a truck that's going to drive across town. A rail car is got to be done in sequence. So they're going to show up not necessarily in the order that you want them. The second thing is, you really can't tell from the outside of the rail car what's in them, can you? We can't tell here which one has the red pellets. Well, how do we know what's in a rail car? Well, every rail car has associated with it a bill of lading, and that bill of lading has information about the product. It has information about the customer, where it came from, things like that. But it also has the vehicle identification number of the rail car. So in other words, for every rail car, there is a bill of lading. But just like the rail cars come at different times, so do the bill of ladings. They might maybe come by email. That's a pretty common way. It may come to you on a website or something like that. They may come at totally different times and dates than the rail cars themselves. So in this case, the rail cars might show up 2 weeks after we've gotten the bill of lading. The next question is, how do we connect them together? You know, the rail car doesn't roll in with like a bill of lading stapled to the side. How do you connect them? Because what we really need to do is we need to match them together. We need to make sure we've got the correct bill of lading with each rail car. They have to be connected. They have to match. So the common link between them is the vehicle identification number. Now, it is marked on the outside of a rail car, and if it hasn't got graffiti over the top of it, you can usually read it. And we're going to get into talking about that. But before we do, let's talk about what could go wrong. What is the cost of unloading a rail car into the wrong destination? Let's go back to our example here. What's the cost of putting the red pellets in the blue hopper? Well, it could be pretty bad. Already you can see that if we did that, if we unloaded the entire rail car into the wrong hopper and we mixed the product, we've already wasted a whole rail car full of product. That could be hundreds of thousands of pounds worth of product. Now we need another rail car full of product. Now we've also ruined the product there in the blue hopper. And by the way, that might be a huge, giant silo, a very tall silo. We've got them drawn very small here, but those could be very large. So we could already have wasted the cost of getting the rail car there. We wasted the time to get the rail car. We need to get another rail car. That's not going to be this afternoon. That could be weeks to get another one scheduled and through the rail system. Now we've got to throw away this product that's in the hopper. Now we can't use that product, so maybe production has to shut down. You can kind of imagine it sort of snowballs out of control. And let's look further into the plant. Let's think about the worst case. We mix those raw ingredients, and now the red and blue pellets are kind of mixed. So I don't know, maybe it's a purple mixture. Maybe it's some sort of liquid, so it's purple. Well, it's not only maybe in the materials supply hoppers. You know, it might have worked its way into the prep area. Maybe we're blending it together. Maybe we're processing it in some way, cooking it or something else. Pardon me. Maybe we're packaging it. Maybe we are storing it in our warehouse, and maybe we're shipping it, and maybe we're ultimately getting it to the point of sale. Maybe it's in the hands of the customers now. So what happens is the farther along that this product gets, the more money it costs us. So the farther it gets, the more expensive the error is. If we can catch it on the early part, we've already said that it can be pretty expensive because we've got the rail car, we need another rail car, all those things. But imagine if now you have run it all the way through the system, all the way to the point of sale. That's a very expensive situation. So it's pretty obvious that we need to prevent this mistake back at the beginning. We need to prevent the unloading of the wrong stuff into the wrong hopper. We're talking about a lot of volume. This is not a shopping bag full of the wrong pellets. This is a rail car with hundreds of thousands of pounds. It needs to go into the right place. So what's the next step? Well, the next step is a procedure. Well, what's a procedure? We're not coining a new term here. A procedure is just a sequence that you follow. It's a set of rules. It's an understanding. Whatever you want to call it, it's maybe a list of steps. Let's look at what that might be. The first thing we could have is we could have a manual chute. Let's go back to our example. We don't have any automation, any limit switches, anything like that. So we just know that in our procedure, step one, check the clipboard. What position do we need the chute to be in? Step two, go to the platform and move the chute. In this case, it's in the red position. Maybe it needs to be in the blue position. Step three is turn on the motors. Maybe there's a button on the floor, start stop button, something like that. And we would just turn on the motors once we're sure that everything's ready. And then how do we know what happened in the past? Like, what did we do yesterday? Well, we would maybe initial the paperwork on the clipboard, and then we'd file the paperwork. And we'd file the paperwork in our historical logging system. It looks a lot like a set of file cabinets. Maybe that's what it is. And we would file away the system for another day under maybe today's date or whatever. Well, what could possibly go wrong? We've got this procedure. If everybody follows it, could be okay. Well, what could go wrong? Well, here's the root problem of a procedure is that a procedure is just a list of steps. But what if you had a new operator, or what if there was a verbal communication that was wrong, or somebody messed up? There's nothing really preventing you from just turning on those motors, in step 3, skipping over step 1 and 2, just turning on the motors. The diverter's in the wrong position. It's going to the green hopper. We got red pellets, and you can imagine that there's disaster. And then the next thing that's a little bit of a problem here is that maybe this is the way our historical logging system really looks. It's overwhelming, all these papers. We've got years and years of papers. They're all in the file system. And imagine if somebody said, hey, let's look at what we did last month or this time last year. We pull out all those papers. Now, what happens if they don't find their way back to the right place? We'll never find them again. You can imagine if they went in the wrong drawer, we're not going to look through all the drawers of all 10 file cabinets looking for the right paperwork. So once they go to the wrong place, it's going to be really a problem. Well, what could be better then? What could we do better than a procedure? Well, what we want to do is we want to prevent some of those procedural problems. We want to start to build a system. Well, what's a system? Well, a system is an assembly of things that actually prevent making the mistake in the first place. So we're going to have a few building blocks we're going to talk about next. Here's some building blocks that most factories have now. For example, we have some HMIs, we have a PLC, maybe we have some servers. All those things connect together to show information to the operator, to get information from the operator, to verify positions and things like that. And an inherent part of this system is the historical logging system is now a server logging things in software. We've all searched Google a million times. You know how easy it is to find things and filter things and do things like that when it's on the web. That's the sort of thing we can have inside the factory, way easier than file cabinets. Also, we could have, we could have some computers on the internet, and those could be connecting remotely, and they could be looking at situations in our system. They could be remotely monitoring. They could be looking through historical records, all those things over the internet. So back to that root question about what is actually in the rail car. How can we know what's in the rail car? Because they all just look like rail cars. They're rolling in. They maybe have a number on them. But how do we really know what's inside them? Every rail car in the United States, you may not know this, has a tag, an RFID tag in the side. It's on the bottom right side of every rail car. So whichever side you're looking at, it's on the right-hand end. And that tag contains various information. It has the vehicle ID, and it has things like the length of the car and things like that. Well, what actually is an RFID tag? Let's talk about that real quick. Here's some examples of RFID tags. Let's start on the bottom right. You can see this is a plasticized one, but it's just pieces of foil with a real tiny integrated circuit integrated in. And you might be wondering, but there's no battery, there's no source of power in these things. These things get their power from the transceiver that's trying to read them. And it gives them just enough power to basically retransmit the information on them. And it could be several hundred bytes of information. And so they don't need any power. They could be, in things. If you have a toll tag, you already have one in your car, and I'm sure you've seen tons of other uses of these things. As we go around the page here, these are all printed RFID labels that are on like a piece of paper, like on a sticker that you could stick onto something. Here's some other examples. These are plastic ones. As we go from the right-hand side, they're encapsulated in plastic. They could be mounted to things, strapped to things. The one on the left is like the electronics are inside that heat shrink, and there's just 2 pieces of wire for the antenna. And that's kind of a cool configuration. You can imagine you could maybe put that in a pallet or something. But when we think about the rail cars, the rail car RFID tags, those are encapsulated in some really tough plastic. And you can see it here. Here's one with over a sheet of paper, so you can see about the size of these things. These are actually bolted right to the side of the rail car, and they're pretty tough. And you could just walk up and read them with a reader on the side of the rail car. Well, what kind of reader do you need to read a rail car RFID tag? Well, one like this. This is a RFID scanner. This is a combination RFID and barcode scanner that we got from our friends at Buckeye Mountain. And this has looks a lot like a phone on the top. It runs Android operating system. It's just a standard scanner. And then that thing in the front, that's the RFID scanner. And then the barcode scanner is a camera and laser coming out the front of the tablet. So this is just like I said, like a phone. Here it is running the TransferMinder app, and that is just a web app. And we'll talk more about that in a minute. But let's get back to talking about the scanner itself. So this scanner is capable of Wi-Fi. So this means that it can talk to a server. And in this case, we have a web application. It's running on the server, and the scanner can talk to it over Wi-Fi. Now, this is very typically a private Wi-Fi, not a public Wi-Fi. This is not the Wi-Fi like in the DFW airport that everybody can connect. This is private. And then also the scanner has RFID, so it can scan the RFID tags. And it can also scan barcodes. So now we can scan barcodes, RFID tags. We can talk to the server, all with this scanner. Let's talk about what a QR code actually is. Here's an example one. This is just, you've seen a million of these. These are the ones with the little squares. These have largely replaced the 1D barcodes, the classic picket fence. Those are definitely still around. You see them at the grocery store all the time. But the QR code is one of many types of barcode configurations. This is a very popular one. It can hold a lot of data into the little square arrangement. And this one here is one that we printed on some aluminum. This is called Durablack, and we engraved this here in our shop. This is a very tough aluminum. This is the same material that is in the nameplates that are on the side of like industrial motors. So if you look in your plant, those nameplates on the side of the motor with the horsepower and the kilowatts and the full load amps, things like that, this is the same material, and we can actually cut these QR codes into it. These are engraved, so they'll last a long time. They're pretty tough against the weather. Now, where could these QR codes be used in this sense? Well, what we could do is we could have the suppliers of the railcar material put them on the bills of lading. And we could actually have them encode things like the BOL number, the name of the product, the lot, and especially the vehicle ID. And if they gave us that paperwork with the QR code, then we could simply scan them with our scanner, and then we could scan the rail car when it got there. And now we can match them together. We can know what is at site. So for example, here's TransferMinder. We can see that we have a vehicle. It's the KDAL 1 is the vehicle ID. We see at site, we have the rail car, we have the BOL at site, and we can see, hey, that's the blue pellets, 523. And now we can match those two together. Well, how do we actually, back to our original question, how do we make sure that we're unloading the right rail car? Well, since we already have a scanner, now we can scan a barcode. Remember that aluminum label I just mentioned? It's really tough. That can be attached to the unload station. We can scan the unload station, we can scan the rail car, and then the software can figure out, yep, that is the right rail car. That's what we need. That is the one with the proper product. Then we can see that that's got the blue pellets. It's at unload station number 1. It's cleared for unload. Everything is good. Well, how does this all connect together? Well, it connects together like this. Starting from the left, we have the bill of lading with a QR code, and the QR code contains everything about the shipment of that material in that rail car. We've got the rail car itself with an RFID tag so we can identify it with a scanner, and we've got a barcode at the unload station so that we can scan the unload station. that scanner doesn't really have anything on it that's really amazing. It's just a browser. It's just a web browser pointed at a web app on the server. It's a lot like if you take your smartphone and point it at Google and search around. That's the same thing. There's nothing special on your phone in that case. It's just a web browser. So that server talks to the PLC, and in a lot of factories, they use PLCs. The PLC can control turn on and off motors, and it can see things like limit switches and move diverters and things like that. And both the server and the PLC can talk to the HMI. Some customers call it an OIT, operator interface terminal. So we could actually see the operation. We can see the equipment. We can also see the web app. And so when you kind of tie all this together, we now have a system. We've matched the rail car to the bill of lading to make sure we know what we have at site. The second thing we've done is we've validated the rail car at the unload station to make sure we have the right rail car at the right unload station with the right product that we need. The third thing that's happening is the PLC is positioning the diverter in this case. It's putting the diverter in the blue position B there in our drawing, and it's verified the path and make sure everything is physically ready. Then the HMI has displayed the ready signal to the operator, and then the operator can start the unload at the HMI. And every step along the way was logged by the system, so we know exactly what happened and when and who did it. We've tracked all of that. We can study it later. We can look at it anytime we want. Now, it's important to point out that the difference between the validation system and a procedure is this will not let us turn on those motors to unload that rail car until we have done all this verification. So that's the difference. Even if you went to the push button and tried to start the motors, they won't start unless you have the right rail car with the right material at the right unload station and all the path is verified on the way to the destination. So that's the end of this first part. We do have some screens to look at, but we wanted to just pause before we get to those and take any questions from the attendees. So feel free to type your questions in the chat, and we'll go ahead and answer them. Walter, you have a question there?
Yes, one question was, does the TransferMinder require any special software?
Oh, great question. Let me go back a couple of slides. The TransferMinder is an application we wrote as a web server application. So it looks like you might think of websites that you could visit on your computer or on your phone. And you can just look at it from your phone. You don't have to install anything. There's no special app. Basically, you could be using TransferMinder from a computer, from a phone, or from this scanner, but they have to be allowed on the network. If you're in a factory, you know, IT is typically controlling the access, so you have to have a credentialed device to run the app. That's the difference. So you don't want somebody just driving by the plant, you know, looking at your list of rail cars. So you have to be credentialed and you have to be on the plant Wi-Fi. Great question.
Another question was if the scanner would still work if it was dropped.
Yeah, it could. Yeah, this one that we got this is from ATID, All Things Identification. It looks like they've done a 1 meter test on cement. It's rubberized around the outside. I don't think it would be, survive a battle. But it looks like it's reasonably well protected. Now, I have a phone here, a smartphone. If I drop this from, say, 2 meters over concrete, I don't think it would survive. So the scanner is more robust than that, I think, but it is probably to be treated, like a phone. It does have some rubberization on the outside, but I don't think I would throw it around, and it does have a screen a lot like a smartphone does. Great question.
Another question was, do I have to have a PLC already installed to use TransferMinder because all my valves and motors are currently manual?
Oh, yeah, great question. Yeah, no, what we've drawn here is a typical scenario in a plant, but that's a good question. What if you just wanted to see what the rail car was and you really wanted to just have clipboards? You just needed a scanner to scan the rail car. We can definitely do that. And if you look at our website, cates.com, and go to products and pick TransferMinder, there's a little chart, and it's not specific, super specific on the costs and the options, but it kind of shows you a progression from just scanning the rail car to identify what they are, all the way up to integrating with your PLC and your HMI, things like that. So there's several steps in between. If you didn't have a PLC, you may want to start adding things like that, and maybe a small PLC with a few limit switches. It really depends how much bulletproofing you want to do to prevent unloading problems or mistakes. Great question.
Another question was, how does the rail car get the appropriate tag?
Oh, very good. Yes, when the supplier sends you the material, let's say it's the pellet supplier and they're sending you blue, red, and green pellets. Those tags are pre-programmed from the supplier of the tags. I think they're sold, by the millions to the railroad industry. And I'm not sure who in the mix there actually programs the tags and encodes them with the identifier. But once they're encoded, those stay with the rail car. So we've got a pile of them here, and they have different encodings already. That one in the example we just showed was KDAL1. That's a pretty short example, and I don't think you'd see that out in the wild. But those come from the manufacturer pre-encoded, and that vehicle ID is, by the way, it's in the RFID tag on the side of the rail car. It's also stenciled onto the side of the rail car, like, SRIX 1234. That stencil on the side of the rail car should match the RFID tag. And then the supplier of the product is going to give you a bill of lading, and on that bill of lading, that is also going to list the same SRIX, 1234, that sort of thing. Good question.
Okay, next question was, how much does the system cost?
Great question. Well, like we mentioned a minute ago, there are escalating amounts of features, and so the beginning system is just a scanner to just go and scan a rail car and see what it is. Now remember, you can just look at the side of the rail car and you can see the identification on the side stenciled in, and it's fairly large letters. So you could then scan the rail car. Maybe you want to log them to the server just into history. That's something we can do. So the cost is probably in the $20,000 or $30,000 ish is the lowest end, for a scanner, the simplest scanner, with maybe a web app. And that depends on whether you have the server already or whether we need to supply a server, that sort of thing. All the way up to, it would be in the hundreds of thousands to fully integrate. Maybe you already have a SQL Server system. Maybe you have a PLC. Maybe you have an HMI that you want to integrate in. So it really depends on what the options and features are that you want, and we can have a conversation along those lines to see what would be, how do you want to approach it, and how much, what list of features do you need?
Next question is, there are several methods to receive raw materials. How does the TransferMinder handle truck deliveries?
Yeah, that's a great question. Now, trucks are not supplied with RFID tags like rail cars. Now, I don't know if that'll ever happen. However, trucks do come, the driver will have with them a bill of lading. So we do have a bill of lading that comes with the truck. But imagine if 5 trucks showed up at once and 5 bills of lading all showed up. Those could get mixed up. So it's not as rock solid as a tag affixed to the side of the vehicle. But the trucks can use the same system because they could have a bill of lading. Remember that you have to have your supplier put the QR code on there in the first place. They're getting more common. I mean, everybody's using scanners nowadays, so it's not at all an uncommon request to the supplier to, put a QR code on the bill of lading. That's not going to be something they've never heard of before.
Which leads to our next question. Our bill of lading does not have a QR code. Can this still be used with the TransferMinder?
Yeah, great question. Yeah, we could have a situation where you could type in the information. Let's say you walk up to the rail car and you saw that it was QRRX 1234. You could type that into the scanner, but what's happening there is you're losing an element of certainty because maybe you make a mistake. Maybe you type in the wrong number. Maybe you remembered the rail car that you passed 20 minutes ago and you thought you remembered it, you just typed it in and you're not anywhere near the rail car. All of a sudden, we're starting to downgrade the bulletproofness of the system. So we certainly could do the manual entry, but it is really a lesser amount of certainty.
Okay, next question was the comment was the QR code looks pretty plain, and the question was, can a company logo be integrated into the QR code?
That's a great question. Yeah, I think back here on the Durablack label, we do show that we printed a logo right into the middle there, Kate's TransferMinder. And our engraver can definitely do that. Our staff is very skilled at doing things like that, to include a logo or a name or something right into the QR code. And the scanner doesn't care about that.
Okay, next question is, can someone driving by manage my rail cars with their phone?
Yeah, remember I mentioned earlier, obviously the IT department's going to want to be on top of things. You don't want an open Wi-Fi system that any passerby can simply, connect and go to your TransferMinder. You'd have other problems happening if that was the case. So it definitely needs to be a private Wi-Fi. The server, there'll be names and passwords, the usual things in the plant.
Next question is this TransferMinder an app on the Apple Store?
Great question. Yeah, this would just be simply the scanner with a browser. There's very few requirements the scanner has to have, but what it has to have is it needs to have an RFID scanner that is railcar tag capable. That is not any RFID scanner. There's only a few out there that will read rail cars. That's really important. So the second thing it has to have a barcode scanner. That's more common, barcode scanners are. And the third thing it has to have is a web browser. And then one little bit of software it has to have is called a keyboard wedge. And that just allows the scanner to put its scan into an entry field on the app. So if you were to go to a scan, here's a page, you can see this is the TransferMinder app. To get the scan into the scan box, that's called a little piece of software called keyboard wedge.
And the last question is, does this TransferMinder eliminate the paperwork for railcar unloading?
Yeah, it can. It can completely eliminate the paperwork. You might still want to have paperwork in parallel for a while to build confidence from the operators in the system, but it definitely could replace the paperwork. For example, here's two instances of TransferMinder. On the left, we see a small size browser, like maybe on the scanner that you'd see, kind of a narrow window. And then on the right, this might be what we'd see on a computer. And it's the same web app that you're looking at. One is on a computer, one is on the small scanner. But you can kind of see that we can see what's going on, what's at site. We can see this rail car is there, what's in it. We can see the last action. And if we were to go over and look at some of the history, this is the scan history right here, we can see what has been scanned. We can see the time that it looks like I myself scanned some green pellets in. This is a BOL that was scanned, a bill of lading, and I can see the details of that scanner. So it's very handy in that you could use a phone or a tablet, like an iPad or something, or a computer, or the scanner. But again, they do have to be on the network and secured. There's a help system built into the product, so we can go in and take a look and see the instructions right on the device itself. And I thought what we would do is just take a look at, for example, the help page. This is actually a live shot of running the app. So let's just go. We clicked here, went through the menu, go to the help page, and then we can kind of scroll down and take a look at things. And it can actually just teach you how to use the app. So that just is a way to walk through the help system. Additionally, what we have is we have a situation where we can look at everything that's been done in the system. Remember, we talked about the historical logging. But here we have a situation where we can scroll through who did what, and it shows the operator. We can see that Fred Jones just logged in, and Mary Sanderson scanned in a station, and before that scanned in a bill of lading, things like that. A bill of lading was received. All those things. A vehicle arrived a little bit before that. So we can see all the history. And here's an example of what we can do, another video of the history. So let's take a look. We go down here to history, go to actions. This is all the actions that have happened. We can kind of scroll down and take a look. If we wanted more details, we can click on the show button and see all the details of some of these things, or we can filter. For in this case, we're going to type in KDAL and apply the filter. Now it's only going to show us the entries with KDAL in it. So we can look through and we can kind of compare, and you can imagine how that'll be handy to find out if something happened yesterday we wanted to investigate. We could just go to the history and take a look at what happened. So that's about it for today. We wanted to thank you for attending. Oh, there's one more question. Go ahead.
The last question was, with this TransferMinder system, what PLCs are compatible?
Oh, great question. Well, it really could be a variety. Right now, it is set up to talk to a ControlLogix PLC, but we can talk to another kind of PLC from the server, another brand. It could be really any of the major brands, but we'd probably want to talk about what you had and then see what integration was required that would talk to it. Another question? Go ahead.
The question was, where is this data stored?
Oh, great question. This data right now is stored on the server, but it kind of depends on the customer how extensive you want to have the backups. For example, if we supply the server, we'd supply the server with like RAID 1 hard drives. That'd be redundant hard drives so that if one hard drive failed, you wouldn't lose all your data. But we definitely recommend that data be backed up somewhere else as well. Just like really anything, you don't want just one computer sitting there with no backup. That's just not a good policy. So you'd want to back up that data somewhere else. But right now, that data could theoretically just live on that server forever. Another question, go ahead. These are great questions.
Okay, so this question was, so the data is stored on a server with SQL?
Yeah, that's a great question. Right now, the TransferMinder is built on a very small SQL platform called SQLite, and SQLite is a very small database. I mean, it can hold a lot of data, but it's a very light package, and it's used for a lot of websites out there in the world. It's used in, I don't know how many, hundreds of thousands, maybe millions of places. However, if the customer had maybe like a Microsoft SQL server, maybe already had a system set up, the data could certainly be put in that system. We'd have to have access to that database and things like that. So it really depends on what the customer wants. If the customer has nothing at all, then we can specify the whole thing, supply a server with SQLite, put all the data there. If the customer doesn't have a PLC, then we could maybe add a PLC as part of the project and just do some minimal interlocking to prevent maybe the unloading motors from starting and monitor the limit switches. If the customer doesn't have an HMI, that could be part of the project. It could even be like a web app. It doesn't have to be a standard, OIT or HMI program. It could be anything. So all of these questions kind of depend on what does the customer have now and how much do they want this system to do? How many features and how much integration with their existing system? But we can talk about that, and we can go to the site. We'll go with our sales team and ask questions and see what the customer wants to accomplish. I'm pretty sure that a fairly big customer that has different rail spurs and a lot of equipment probably already has a PLC platform. They may already have some servers, so we might not need to supply those pieces, might just need to integrate this in. By the way, I'm guessing people are wondering, we're going to talk in the next couple of webinars about what makes a system like this a success and about training and things. That's all coming up, but I wanted to point out that once you put in a platform like this, you can kind of imagine there's other things you can do with this. With this scanner, we could integrate in more things. Maybe you're receiving other products. Maybe there's other things you want to scan and you want to have history of in the plant. Now the platform is there. We can build upon the platform and do some more things. Go ahead with the next question.
Okay. Question was, how much time is required for implementation of this system?
Yeah, great question. Yeah, it depends really on the complexity, but end to end, we'd want to first go into the plant, take a look at it, talk to the customer. We'd go with the sales team, talk to the customer. What do they have? Do kind of an audit, see what they have, what do they want, how much training, things like that, and really see what they want. So you can kind of imagine on a scaled down small system where you just kind of wanted to read the rail cars and maybe log them to the database for some history. If you wanted to start there, that's a fairly small project and that could be done fairly quickly. But that would be measured in weeks. If you wanted a bigger system, if we were going to supply maybe a small PLC and integrate in, we'd need to mount limit switches maybe and interlock the PLC with the motors, things like that. That's probably now measured in months. And then if we integrated completely into another system with the customer had the servers and the customer already had the PLC, that's also measured in months. It's just really a matter of how many features we want to have in the system, how much we want to interlock in the system, and maybe the customer says, hey, by the way, can it also do this? And the answer is probably yes, because we have a very capable scanner. We have a web app, we have history, we have a database, we have all the building blocks to build a lot of cool features to do other things, maybe in the unloading and receiving area, maybe all of these things. So we're really just talking about getting a platform in place and then we can build upon it. Great question. All right. Well, I think that wraps up the questions. We are so excited you attended today, and we invite you back for webinar number 2 of the validation systems. That's going to be on March 1. And we've got 2 more webinars about validation systems planned. So we're going to be talking about the success criteria, why these systems like this work and why they don't work, what can you do to ensure that they work and they're successful. We have some training elements. We have some more technology discussions and things like that, more to build on it. We hope you'll come back for that one. But thank you very much for attending. A little bit more information is available on our website, cates.com, and we'll see you next time. Thanks very much.